Internal energy is equal to the total energy of all the particles in the system. So if we have an object like a book per se, and we calculate all the energy of those particles because those particles are in motion, and we add them all up. So we take the energy of each single particle and add them all up. This is equal then to the internal energy of that object. The internal energy, just like all types of energy, are scalars, meaning it has no direction. It is related to the temperature in that as the particles move faster, the energy increases. And as the particles move faster, we also know that the temperature increases. So as the temperature goes up, the internal energy will also go up, and vice versa. As the temperature goes down, the internal energy will also go down. The symbol for internal energy is the letter U. Although I don't know a reason for that, it is pretty common. The units, we're going to be working with joules, but those are not the only units for internal energy or any type of energy. We can also measure internal energy in calories or BTUs. And BTU stands for British Thermal Unit. But again, most scientists will use joules, so that's what we're going to stick with. Now, the conservation of energy, as we have said it before, is written as the change in kinetic energy plus the change in potential energy is equal to 0. So however much the kinetic energy would have gone down, let's say that the kinetic energy went down by 10 joules, that must mean that the potential energy goes up by the same amount. It would go up by 10 joules. Now this, of course, is in the absence of friction. So what happens when there is friction? Well, friction is going to cause some heat, which makes the particles move faster. So it's going to increase that internal energy. So the way that we want to write the conservation of energy, even with friction, is that the change in kinetic plus the change in potential plus the change in internal energy is equal to 0. So let's say that the potential energy goes down by that 10 joules, but the kinetic only increases by 8. So that's a more real-life scenario. So what happens to that extra energy, those 2 joules that are left over? Those 2 joules then go into the internal energy, which would increase that internal energy. Because it would be heating up, it would be making the particles move faster. We can also think of it in terms of other non-mechanical. So this is our non-mechanical forms. So other non-mechanical, we talked about heat, making the particles move faster. Sound. Sound is also produced because I'm vibrating the air molecules as we speak. And so again, it's making those particles move faster. So sound can also be explained through this internal energy change.